Greetings, Pepin Falcons, and welcome to another edition of Math is More Than Fun at Pepin. Don't be too concerned about this. That's his favorite pillow, and that's the way he takes naps. So don't worry too much about that. I'm actually a little nervous about this presentation because I struggled with this when I was in ninth grade, and it was a long time ago. When I was learning algebra and doing my best in ninth grade, I did not get this right away. So I want you to understand that. That's why I'm going to pause. I still have a poster up here for it, but I'm going to pause on the particular steps. I want to go back. This is going to apply to two of these. This one, where we combine like terms on each side of an equation, on each side. This one and this one, all right? When we combine the like terms, if we do it correctly, as you know, the equation will remain the same and equal. And then also this one, where we're combining like terms across the equal sign, where you are adding or subtracting to actually remove one of the terms that's on one side or the other, but being very careful to do the same thing on the other side so that you remain equal, and that way it takes your problem and pares it down to where you can get x equals or a equals, whatever it happens to be. I'd like to define a couple of terms for you here, and I want to cover this up because I really want you to see this. You need to let me know in school if you watch this and you don't understand it. We're going to take two terms. We're going to take factor and addends. Factor is the first one. Factors are items that are multiplied. It's as easy as that. When you're multiplying, say, a single digit times a 4-digit number in the thousands or a 5-digit number in the 10,000s, you're still multiplying one number times another number. And then you do that, and then you do one number times another number. Those items, when you multiply two numbers together, you have factors, okay? So here's some examples of factors and some of the ways that they've been characterized over the years. We've used an X and also parentheses to show multiplication, and then it was reduced to a dot. You have to remember, when the mathematicians of old, when they were working out all of these operations and so on, and figuring out exactly how math worked, and trying to explain it, they had to use ink. They used ink with feathers or quills, and when they ran out of ink, they had to leave their comfortable abode, wherever they were, and borrow or steal a donkey and ride over the mountain and get another jug of ink and bring it back so they could continue. They didn't have pencils, they didn't have paper, and bring it back. And certainly, because of the way old mathematicians looked, the kids would generally throw food scraps or rocks or stones or whatever at them, sometimes breaking the jug, and they'd have to turn the burro around, go back over the mountain, get another jug. So they're looking at math shorthand. If you're doing math all day long until the sun goes down and then you get out your candles, all right, doing an X like this takes a lot more ink than just putting a dot there. So when these people would communicate with each other that, hey, why don't we stop doing that? We'll use this just for large quantities in the middle, but let's just take it down to a dot. If you see a number with a dot and another number, that means multiply. And they all said yes, and on they went, all right? I'm replacing this line with this one, and what I'm doing here is I'm replacing one of the numeral factors, one of the integers, with an unknown, all right? We've got the same thing. We've got 6 times b. We have 4 times b. We have 9 times b. And my knuckle hit this b when I was holding this up. But this is what it looks like now. This is what we are working now. You are in algebra now. You're not in arithmetic class anymore. So a 9b, a 4e, a 3c, a 2x, a 12y, whatever those happen to be, this is multiply. We took the shorthand a little bit further, and we're not even putting the dot in because it's not necessary. And much of algebra has come through printing now, and that's an extra space in there. We don't do that. We don't do that anymore. That was probably 100 years ago. This means multiply. When two factors are, when an integer and an unknown, a letter of the alphabet, are sitting side by side, they are factors. They are factors. They are to be multiplied times each other. In other words, B is something. We don't know what it is, but we've got 9 of them. It's 9 times B. Okay? Now, what is the difference between a factor and an addend? Easy. Addends are items that are added. I think you may have met this word maybe in 6th grade, 7th grade. Addends. Those are items that are added together. 5 plus 2. We know that's 7. 12 plus 7. We know that's 19. Easy stuff, right? 27 plus 4. We know that's 31. You know what this is? 6 plus B? 6 plus B is 6 plus B. Why? Because we don't know what B is. We cannot combine that B with that 6. We can't combine it because we don't know what B is. So this does not change until we figure out, we do maybe an equation and find out B equals something, and then we can add it to 6. But until then, we don't know what B is. And so we cannot add it to 6. If this seems very simple to you, that's good. I'm glad to hear that. So what that means is you're not going to have, if that's you, and you're thinking, come on, Mr. Newell, can we move on and get, okay, well, let's see. That means that you know the difference between these two words, and I hope you do. You know the difference between these two words. So when you occur something like this, 4a plus 3, you know that's never going to be 7a. There is no way that is going to be 7a. This 3 cannot be added to this 4. Why? Because this is a factor. This is already taken up by the A. I used to tell, when I taught prisoners, I used to tell them, think of this as being in the house. This is a husband and wife, and this is somebody outside the house. Doesn't belong in there and can't get in there. This 3 cannot combine with that 4. Absolutely not. That is a factor. That is an addend. This whole thing is an addend. This whole thing gets added to 3. Now, do more of you understand this? I hope. All right, can I do another one? How about 3y minus 7? All right, wrong one. Sorry. 3y minus 2. Somebody, not you guys, but you know, maybe at the other Pepin or something, they're going to want to say 3y minus 2 is 1y. No, it's not. This cannot be combined with this. This is a factor. This belongs to the y. There's only one way to get rid of that, and that's what we're going to find out in, I think, one more lesson or 2 more lessons. You're going to find out how to change that 3 into a 1 so you can actually get y equals. All right? One more example. All right? Let me do 12d plus 5. Once again, this you have to be able to take these right here and imagine them this way. And if you can do this, if you understand this first straight up, then you're fine. If you never do this, if you would never ever, I mean, if you saw somebody do this, you recognize right away that can't be 7a. You can't add the 3 to the 4. Great. So that's good. You get it. Some of your classmates, some of the other people watching this may not get this yet, if you need to, think of this way. This is 12D. In other words, whatever D is, D might be the number of battleships. The number of battleships in Norfolk, Virginia. We don't know what D is, but there's 12 of them, okay? And we want to add 5 to that. Think of it this way. Split it up a little bit. Make that look like an outsider. Up here, because you see it like this, especially if it's printed. You see it nice and close, too cozy, that for algebra. Split it up. Put this over here where it belongs. Get it away from this, because then you might be able to see this is something, and it's going to be added to this, whatever it is. Don't just jump on the 5 and the 12 because you know it's 17. Don't do that. This cannot be combined with this, ever. You cannot combine those two. You have to do something with this and separate it from that in order to add something there, and that's what we're going to do. In most cases, what you are going to do, and we're gonna see this in the very next lesson, if you have this and you're doing this, what you're going to do is get rid of that 5, and you already know how to do that. You're going to subtract 5 from both sides. I don't know what's over here. We're not going to go that far. It doesn't matter. We just got rid of that 5. We just got rid of it. It's sitting there. It's causing problems. So let's get rid of it. And we just subtracted it. Remember, when you're working with an equation, you can subtract anything you want. Anything. As long as you do it to both sides of the equation. I'm much more comfortable getting rid of this. Now I bring my apple down. And look what I have. Made it nice and simple and cleaned it up, all right? And remember, some of these equations are going to be like this, and you're going to just take it down one step at a time, do the same thing to both sides. Here's one of those things I was telling you to look for, a line through a problem where you do the same thing to both sides, okay? And that's good sound problem solving, and it'll work for you every time, all right? Very good. I'll look for you at the next video lesson. Bye.